All right. Good afternoon, everyone. Thank you all for coming and staying that late. Super excited to be here. So if at any point I pass out, just make sure your cameras are ready to get it. So today I want to tell you the story of how we chose our queuing mechanism in our Node.js backend distributed servers, and why this choice is important for you in order to meet your system and your business requirements. So I'm Liad, and I'm 33 years old, and for the past year or so, I've been leading the SaaS applications backend team at Tomorrow.io, where I started as a senior backend engineer about 2 years ago. So just in a few words, Tomorrow.io is a SaaS company. We provide weather intelligence. We gather weather data from all around the world, and we serve that data through our platform over an API and a web application. We also allow you to create insights on top of that data and get alerted on weather events before they happen. For example, imagine that you work for the governor department in the state of Florida, and there is a hurricane heading your way. You want to get alerted about that hurricane in advance before it hits, because you have to take crucial actions in order to save human lives. Another example would be from the logistics world. You have a supply chain and you have to deliver goods from one point to another. You want to make sure the roads are clear and they are not blocked because of severe weather events. And that could save you. If you know that in advance, you can recalculate your route in advance, and it can save you a lot of time, money, and even human lives. So today we handle hundreds of thousands of weather events every minute, and we provide weather data to some of the biggest players in the market, like Uber, Tesla, AWS, and even the US Air Force. So in the next about 13 minutes that I have left, I will walk you through a general overview of our system, just to get you into context. We'll talk about the tools that we use, and I'll explain how and why we chose our queuing approach and how and why we changed it. So our system is deployed to a Google Cloud platform, and it combines Node.js microservices and Google Cloud functions. We use common databases like Postgres, MongoDB, Redis, and others. And it includes both REST API and events-driven architecture. So when we got to the point that we had to choose the way we're going to handle these events, naturally, we chose Google PubSub. Some of you may know it, and if you're not familiar, as you may understand from its name, it's a publisher-subscriber service provided by Google Cloud Platform. And the concept is pretty similar to other solutions you know in the market, like SQS, RabbitMQ, Kafka, and others. So PubSub offers you two methods for consuming the messages. You can use a push subscription, and you can use a pull subscription. We chose push subscription, and I will explain what it is. Push subscriptions, it's a hard word to say when you're nervous. So I'll try to avoid it. It works similarly to webhooks. The publisher fires a single message over an HTTP post request to a predefined endpoint. And that consumer handles the message, and according to its reply, if it's a positive reply, an HTTP response, then the message is acknowledged as it was processed, and if it's not, a retry is triggered, or according to whatever you could figure it. So why did we choose push in the first place? Like every other startup, we started small. We had relatively low traffic. We handled just a couple of thousands of events, and we handled just a couple of thousand events, and everything works. And the push mechanism worked very great with our architecture. We also had to move fast. It worked great with our serverless architecture, as I said, and it was simple to implement. We could use express abilities, and it really suited our scale at the time. So we had incoming weather events. We had our cloud pub sub firing these events, and in our case, triggering cloud functions to handle the logic. It was in high level reading from a database, getting some more information from other services, and writing back to making the calculation, and writing back to another database, and triggering the next event. And it worked great. In fact, events were coming in, our function handled it well, and everything went smooth. In fact, it went so well that our traffic started to grow. We got more events coming in. We had more users and more requests coming in. And at some point, that architecture and that system couldn't hold the load. So we started to experience connection issues with the databases. We started to experience a load on the databases. And we had to, at some point, we started to experience data loss. Because when the publisher pushes the messages and the consumer cannot handle the load, the request starts to fail. And we started to lose data. So we scaled up. We scaled up our databases and our servers, and it did the job. But then the traffic grew more and more, and more and more. More events came in, more API calls. At some point, we started to lose a lot of data. We couldn't handle the load. Sounds familiar? Let me take you back a little bit for the time where you were a student. Imagine that you're in a lecture, right? And you need to take notes. And at some point, the lecturer starts to speak really fast, and you start to lose track, and you really can't handle that load of writing all the notes. So you poke your friend and you say, hey, why don't you help me? You write some of the notes, and I'll write some of the notes. Sound great, right? He starts to write, and everything works smoothly. But then he starts to speak faster, and he's starting to lose space again, to lose track again. So you poke the next friend, and it helps, and it goes faster. And he pokes the next friend, and eventually you have the entire class working together and writing the notes, and it's great, but eventually you run out of people in the class, and you cannot scale anymore, and that wouldn't work. So we had to stop. That was very similar to the way our problem looked, and we had to stop and rethink. What is the problem? We have an event-driven system, and we have to ensure at least once delivery of the messages, because we don't want to lose any data. Every lightning counts, tell you that. We had to be prepared for a quick scale, and we couldn't go with the method of throwing money at the problem anymore to solve it. We had to start thinking cost-effective. This is where we started to think about moving to the other method PubSub allows us. Now, we didn't do it in the first place because, as I said, we had to move fast, and it was easy for us to implement at the time. And this change required us to do some major changes in our architecture, and I will explain it in a bit. But some of the differences between push subscription and pull subscription, nailed it this time, and is the fact that in pull you can increase the throughput of your system, and you can still control the pace. The main difference here is that in push subscription, the publisher controls the pace, and when in pull subscription, if you plan it right, you can make it in a way to work in a way that the subscriber is the one dictating the pace. So the changes we had to do, we had to switch some of the architecture from Google Cloud Function to Kubernetes microservices in Node.js. And the main idea of this new way we worked was that by controlling the number of pods that are subscribed to that topic and consuming, and by setting a certain number of messages to be pulled in every bulk operation, we could actually calculate and control the exact pace we want to be consuming these messages. Of course, we paid it with a bit of latency, but it was acceptable. And that made us the option that allowed us to use smaller machines regarding our databases. It helped us to be very accurate in terms of the resources that we use in our system. And we could measure our performance much better. We could use custom metrics in all of our operations. And basically, it helped us scale. There was no data loss anymore. And we could process much more events after that change. So this is how it looked generally. Instead of the Google Cloud Functions we had before, we had multiple instances of the same service that could consume the topic. And when we had large peaks of information, we could put more pods, but the operations were smarter. We didn't handle every message on its own. We handled bulk groups of messages all together. The writing and the reading operations became more aggregated and more efficient after we changed to that approach. So, don't have much time left, so I'll get to the bottom line. The thing I want you to take from this is that you have to, there's no right or wrong answer. You have to adjust the solution to your need. At first, this push method worked great for us because of the scale we had, and we had to move fast. But when you want scale, you have to control the pace and the way you consume your messages and how you handle it. So the change we did helped us to achieve that, to control the consumption rate. It led us to better performance. We had more predictable behavior because we could measure ourselves better, and it helped us to save resources and, of course, by that save money. I see it here. Okay, so thank you all for listening.